Hello students, now we are going to discuss some numericals on equilibrium, that calculation of Kc and Kp, equilibrium constant in terms of concentration and in terms of pressure. What is the relation between them and how it will be calculated, we will discuss today. So first problem, first numericals, we will discuss like this. That formation of ammonia, nitrogen plus 3 molecules of hydrogen forming ammonia, 2 molecules of ammonia. For this reaction, the Kp value of Kp is given 49. Value of Kp is 49. Then what will be the Kp value? What will be the Kp value for the reaction ammonia G? All are in G. Number 2. What is the calculation of Kp for this equation? But we know that in the characteristic of chemical equilibrium, that is characteristic of a nature of equilibrium constant, when the reaction will be reversed, the equilibrium constant will be also reversed. When any number is multiplied, then it will be the power of the previous equilibrium constant. Already we have discussed. Here it is reverse. Reverse again multiplied by 2. You see, right hand side 2, here left side is 1. That means here half is divided. In the whole equation, half is divided and it is reverse. So as per the calculation, Kp dash will be the 1 of the Kp, whereas it is reverse, that is 1 by Kp. Then here half is multiplied. When half will be multiplied, then as 2 ammonia it is 1 ammonia. As reverse means 1 by Kp, and again half multiplied means it will be the power of half. Then we know what the value of Kp. Here Kp is 49 as per the question. So 1 by 49 to the power half. That means 1 by 7. So this is the answer of Kp dash for this equation. As we are just following the characteristic of Kc, expression of Kc, characteristic of Kc and Kp. Then second question is like this. Equation is given. Somewhat type of equation is given. Equation is like this: 2SO3G convert to SO2 plus O2, then 2 both are in gaseous. Okay. Here what is given? Here Kp is given. The value of Kp is equal to 1.8 into 10 to the power minus 3 kilopascal. This is the given value of Kp. Value of Kp is given 1.8 into 10 to the minus 3 kilopascal, which is how much pascal? You can convert directly. That 1.8 into 10 to the power 10 to the minus 3 kilo means pascal, means it will be again 10 to the power minus 3, again 10 to the power 3. 10 to the power minus 3 into 10 to the power 3 pascal, which is equal to 1.8 pascal. Okay, so this is the value of Kp. But the question is, we will calculate Kc value. What is the value of Kc at 700 Kelvin? Here Kp value also at 700 Kelvin or 700 Kelvin, Kp value is given. Then question is calculate Kc. But we know the answer will be like this. First, you think what will the answer? Which formula will be used? You see, your formula already know the calculation of Kc and Kp. Kc is equal, Kp is equal to Kc into RT to the power del mg. This is the formula. Okay. Here Kp is how much? Here Kp is equal to implies Kp is equal to 1.8 Pascal into Kc RT. Del N value means product gaseous minus reactant. Here product gaseous is 2 plus 1, 3 minus 2. That is 3 minus 2. Here, as R is used in liter atmosphere, we have to convert Pascal to bar or atmosphere. We can convert into this. What is the answer here? 1.8 Pascal is equal to how many bar? What is the bar? We know that 1 bar is equal to, 1 bar is equal to 10 to the power 5 Pascal. So 1 Pascal is equal to 10 to the power minus 5 bar. So here 1.8 into 10 to the power minus 5 bar. Bar or ATM? Approximately 1 bar is equal to 1 ATM. So Kc and value of R is how much? Value of R is your 0.0821 into T is here 700. As per the question, T is 700. Here question is 700 to the power 3 minus T is 1. Okay, so implies what is the value of Kc? Kc is equal to 1.8 into 10 to the power minus 5 upon 0.0821 into 700. Here answer will be how much? You calculate, try to calculate it. You have to practice the calculation. I can calculate speedily. How much answer is coming? Answer will be 3.09 into 10 to the power minus 7. This is the unit. This is the what? Value of Kc. So only same formula we have used. Kp is equal to Kc into RT to the power del N. So this is the second question. Third question is like this. We will calculate. Here one equation is given like this. PCl5G convert to PCl3G and Cl2. But one thing remember, if the equation is balanced, that is okay. If it is not balanced, try to balance it. Here already given in balanced form. PCl5 is equal to changes to PCl3 and Cl2. Both are in G. Both are in G. But what is the question? Question is here 2 mole is taken. 2 moles of PCl5 is taken in a 2 liter vessel. At how much temperature? 327 Celsius. 327 degrees Celsius. This is the given. 2 moles of PCl5 in 2 liter vessel are 327 degrees Celsius. But question is, what is the value of Kc? Calculate the value of Kc when 40% dissociated. When PCl5 40% dissociated, then what is the value of Kc? Because Kc value depends upon the change of concentration of reactant. If 40% dissociated, 2 moles is taken. So you have to use this equation and volume is 2 liter vessel. 2 liter vessel. So initially, if you see the equation, initially it is 2 moles. Then product will be how much? 0. This is also 0 initially. But when 40% dissociated, 40% dissociated means how much left? 2 minus 2 into 40% means 40 by 100. This is the left, because initially it was 2, then 40% dissociated, that means 2 minus 2 into 40 by 100. And how much produced here, or as it is the 1 mole, same 40%, how much produced? Here 40% dissociated means 40% also produced. That is how much? 2 into 40 by 100. Here also 2 into 40 by 100. This is the number of moles. Now how much? That 2 minus 2 into 40 by 100. How much coming? Result is coming. How much? 2 minus 0.8. This is your 2 minus 0.8 moles left. And product will be 0.8 mole, and second one also plus 0.8 mole. Okay, 40% means 0.8 mole. So this is the mass left in the reactant side and product sides. Okay, this is the number of moles. Then what is the concentration? C value will be here 2 minus 0.8, that is left. That is how much difference? That is 1.2. 1.2 moles. And what is the concentration? In 2 vessels, that is by 2. This is the volume, concentration, moles per liter. Here produce 0.8 by 2. Moles per liter. Here produce 0.8 by 2 moles per liter. Both will be like this, because we are converting the concentration, volume given and number of moles calculated. Then what will be here the values? Here if you put this is the concentration left at the equilibrium. At the equilibrium stage, 1.2 moles, 1.2 moles, 1.2 by 2 moles per liter. Moles per liter. Liter of, that is PCl5 is left, and PCl3 is 0.8 by 2 moles per liter, and chlorine is 0.8 by 2 moles per liter. So we have converted the number of moles to concentration. Then we apply the formula. What is the Kc formula? Kc formula is in terms of that product concentration, PCl3 as 1 mole into Cl2 1 mole, then PCl5 also 1 mole. Okay, PCl3, here PCl3, how much? We are calculating in terms of concentration, moles per liter. Moles given means moles per liter we are calculating. So PCl3 value is how much? PCl3 is 0.8 into 0.8, that is which one? Chlorine upon. Then here 0.8 by 2 means here we can write by 4. Here by 4. Then numerator is how much? Denominator is how much? 1.2. 1.2 by 2. By 2 means it will be here. This much. So because 1.2 by 2, it will be again numerator. Here 0.8 by 2, 0.8 by 2, that is 2 is 4. So this will be 2 If you calculate how much is result is coming, you calculate. The result will be how much? You calculate it. Firstly, you calculate what answer is coming. Okay, that answer you will get. This is the value of Kc, 0.8. Here how much is coming? 18, that is 6.4. 6.4 upon 2.4. 2 point something. 2 point here. That result is coming. This is the what? Value of Kc. This is the value of Kc. Okay. In this way also you can calculate what is the concentration given, whether concentration directly given or number of moles given, in volume given. You have to calculate the volume concentration by dividing the volume in concentration in the number of moles, so that you calculate the concentration in terms of moles per liter. So because in the question 2 moles given and volume given 2 liter initially, then at the equilibrium what is the concentration? We are calculating the concentration at the equilibrium stage. Here 2 moles taken, when the reaction start, how much? 40% viscosity means 40% of 2, that is 2 into 40%. That is mass of number of moles of PCl5 left. This is the number of moles of PCl3. If it will be 2 multiplied, then we will multiply 2 again. You have to see the number of moles produced in the two side, reactant side and product side. If the reactant side, product side will be coefficient, then same coefficient will be multiplied here. Okay, so this is the calculation of Kc. Then another question, that very important question, very easy question also. Question number 4. Question number 4 is like this, that what are the data given for the equation that K for the reaction, suppose A, for a particular reaction, Kf value is given. Kf value means the rate constant of forward reaction is given 2.38 into 10 to the power minus 4. And the rate constant of backward reaction is also given. The rate constant of forward reaction, backward is like this. This is your Kf. This is your Kb. Backward, Kf is given and Kb is given. Kb is how much? 8.15 into 10 to the power minus 5. As per the question, forward reaction rate is given, backward reaction rate is given. But question is calculate the K equilibrium constant. But we know that in the chemical equilibrium, law of chemical equilibrium, K, either Kc or Kp, both, K is equal to Kf by Kb. This is the derivation of calculation of equilibrium constant in terms of rate constant of forward reaction and rate constant of backward reaction. So Kf by Kb, Kf is 2.38 into 10 to the power minus 4 upon here 8.15 into 10 to the power minus 5. You calculate how much answer is coming. You calculate now, quickly you calculate. Try to calculate that result fastly. Now use some tricks, mathematical skill and tricks used to calculate the numericals. So that is very important, is because it will take time for solving the problem. Only problem is only to how to solve the problem, how to calculate. You know the formula, you can put the data, but I can calculate you will get the result quickly. So K is equal to Kf by Kb. If you calculate, then the result is 10 is multiplied, just with 10 to the minus 5, 10 to the minus 4 means 10 is multiplied. So 23.8 by 8, result is 2.92. 2.92. Result is 2.92. This is the calculation of equilibrium constant for the reaction Kf, Kb given as per the data. So like this, you can solve many problems related to calculation of equilibrium constant in terms of concentration, in terms of pressure, that is Kp. If the concentration is given or number of moles of reactant is given, how much dissociated. Here 40% dissociated means alpha is given. That is called also alpha. What is alpha? Degree of dissociation. Sometimes question may be given in terms of association also. So anyway, you have to use this formula alpha. If alpha is known, the dissociation is known, then you can also calculate using this formula. Initially how much, then how much dissociated will be deducted. That amount will be deducted, same amount will be produced in the product side. You have to add it. Then you calculate the concentration of reactant product at the equilibrium stage. Then put the equilibrium law of chemical equilibrium formula. Then you will get the result. So in this way you can calculate, but you require practice. Okay? Thank you.